All right. What I've done for your video, rather than me going over how to derive the rules, I found a really nice video on it on Khan Academy. So I'll link that to your email. Watch that first, and then take some notes for me. Make sure your brain's taking it in both ways. You're writing it to solidify that. And then also write any questions that you have for me so that next time I can go over that and answer them with you. So I'll send you the video. They explain it really well, which is why I don't want to make a new video and explain it in a different way. I think theirs is really solid. And it goes through exactly what the relationship is between each of the pieces. What I'm going to do with you in this video is go through these questions. I've chosen these because they act on that video, so you need to watch it first, and because they're quite righty questions, which I know is more of the stuff that you want to cover, just because you're so good with the math stuff already. So, watch the video, pause this, come back and do these questions after to solidify your learning. All right, so real gases have complex behaviours which are difficult to model accurately. One simplified model is the kinetic theory, according to which macroscopic properties, temperature and pressure, can be calculated from simple assumptions about the microscopic behaviour of atoms and molecules. It's very wordy. The actual question is here. Calculate the molar mass of N2O. This is 1 mark. It's also mathsy, so you should be able to do this straight away. Molar mass, I'm going to use my periodic table to help. For nitrogen, for N, it is 14-ish, and I have 2 of them. So that's going to be 14 plus 14, which is 28. I then also have an oxygen, which off the top of my head is 16. Yep. So my total molar mass for this then, I've got 28 plus 16. Then I need my units because they're not given to me. Units for this is going to be molar mass, grams per mole. All right, part B links to the video. State 3 assumptions of the kinetic theory of gases. There are lots that you can choose from. Okay. First, yeah, I'm gonna do all of the ones I can think of. So I think there's 5. You only need 3 for the marks here. You can say that there are a very large number of molecules. That we're accounting for. Okay. You can add that they move in random ways. For number 2, we could talk about how they take up very little volume. We can say that when they collide elastically. And that the time they take to collide, time of collisions, is negligible compared to the time between them. Final bit, we can say that there are negligible electrostatic forces. So these are all things that we think about when we're making the kinetic theory of gases. This is stuff that we have assumed between them. Right, part C, it says, explain why a gas exerts a pressure. Now, he talks about this really, really clearly in the video, and he gives you the example of the balloon. We need to be able to phrase that in a way that suits any condition, though, not just inside of a balloon. So I'm going to say molecules collide with each other. As well as the walls of the container. Right, this is just like the balloon wall that he talks about. When they hit the container wall, they exert pressure. And then the total pressure that the wall feels is a sum of the individual collisions. Now this is a 2 marker, and I've written 3 sentences just to make sure that I'm picking up every single point here. Honestly, you're probably going to get a mark for this sentence and for this one. My final sentence is just to ensure that I've definitely picked up all those, and it took me less than 2 minutes to write that. So I'm not stressed about timing, just doing 1 extra sentence. There is one more question. Explain how you would go about calculating the value of absolute zero using a water bath. Now, this actually isn't spoken about in the video, but we can work it out together. It's also a 3 marker and it's a wordy question. Now, if we have a water bath, also I am not opposed to using drawings to help you in your exam. Drawings help me a lot. Think about what's going on in the water bath. We have a lot of water bottles. We can also use some sort of temperature to help us. To be honest, I'm thinking about my equation right now. Or even I'm thinking about the relationship between pressure and temperature right now. And how I could measure pressure actually. So in the video we talked about how pressure was related to temperature. Like this, which we can rewrite. So pressure, I don't know if you've seen this before, but my proportional symbol, I can just stick this in. 1/T, which is the same as saying this, so PT is a constant. My K here just stands for the constant. Alright, I'm trying to work out the value of absolute zero, which is when energy is completely minimum, so the particles aren't moving. To do that, I'm going to need to plot a graph and basically extrapolate because the conditions here aren't good enough for us to work it out. Firstly, I'm going to take a piece of equipment called an air vessel, and I'm going to pop it into my water bath because it's told me I have to use one of those. So place an air vessel into a water bath. There are other ways of doing this, by the way. This is just what's come to my mind. And this is going to be connected to a pressure sensor. Now, I've come up with that because I need pressure to be able to work out my value of absolute zero, my temperature here. So I know I need something to measure pressure. I'm just going to call it a pressure sensor here. Sorry. Place an air vessel into a water bath that is connected to a pressure sensor. Now let's use my previous knowledge. I know that at T is 0 Kelvin, which is absolute 0. My energy is a minimum. And the particles will have 0 kinetic energy. That's just a definition that we need to know. This means, let's use our knowledge from the video, if they have 0 kinetic energy, they can't exert pressure. They can't move to hit the container walls. So if I'm running out of room, plot a graph for pressure against temperature, we've got pressure and temperature. I can use my pressure sensor to measure what my pressure values are, and I can reduce the temperature, or I can increase the temperature, which is a lot easier to do experimentally. And then I can extrapolate this backwards, right? Once I have extrapolated backwards, I'm actually not going to get a graph that looks like this. It's going to look more like something like this. No, sorry. How do I draw this? Like that, I think. Yeah, so, sorry, I drew that wrong. But you're gonna increase the temperature, find out these readings, and extrapolate it backwards. Once you've extrapolated it backwards, you should get a reading for absolute 0. The reason that I'm doing it backwards is just because of how experiments work on Earth and the conditions that we have to do that. If I'm using a temperature here underneath my water bath, which is pretty easy to do, the easiest thing to do with my temperature is to change it by going up, or I can go slightly down, but I can't bring it all the way down to 0. Right? Imagine you've got a Bunsen burner and you've boiled your water. You can take those readings going backwards. So starting at the highest temperature and taking it down. That's going to be the easiest way to complete this experiment. Absolute 0. I think this question is quite tricky because it pulls on your knowledge of this as well as your knowledge of experimental setups. That's why I've tried to choose this one, just to push you a little bit more. It's still wordy, and actually I think it should be more than 3 marks, but you know all of these things, right? What we're learning to do together is break questions down using common sense, knowledge that we already have, and applying previous knowledge, so stuff like the ideal gas laws. Okay, all of this together is going to get you like your A star. If you have any questions, please write them down for me, email them across. I'm not going to get back to them until the 26th anyway, but it gives me some time to work out how to explain that better if you do have them. Okay. Also attached to the video, there are other steps in it for the Khan Academy one that have questions. If you want to, apply your knowledge over there as well. Most of them will be calculations, but some of them will be wordy questions that can help you. All right, enjoy.